today is to remind you of the bygone era of platform construction here in Stavanger. It came to an end, but I would wish to point out really how the legacy from this era can be used and is being used to capture new opportunities. And this, like so many other things in life, started with an opportunity, market opportunity, a new concept, and of course some very people. But of course it is a giant of a project, a lot of innovation. It was built from 1991 to 95, but really Troll was discovered in 1980, and it took more than 10 years of development to get this to fly. And it all happened, it started, of course, like we've heard already this morning, for us in 1971, when all the very forward-looking politicians and managers have managed to secure the southern part of the North Sea. The oil companies started to wanted to develop oil fields, and this was a challenge that people would be facing, or eventually would be facing. And when you look at that list, water depths, wave heights, 30 meters wave height, you imagine, in the middle of the North Sea, up to 200 kilometers from land, in the middle of the North Sea. They needed to store oil. That was one of the big ideas with the concrete platforms. They could store oil or gas in between in bad weather. Top sites up to 50,000 tons had to be taken out and ready to start to produce at the field. And we had in some of the field, like Troll, soft soils, which would normally entail piling and foundation works, which would be impossible at that depth and at that location. So the concept had to cover that. And you could ask yourself, is this a realistic opportunity for a steel-minded industry? And you would be quite brave to say yes, I would like to say. But of course it started not with a big Troll, but with a small platform, smaller depth. Ekofisk already, you have seen this morning, played a very significant role in developing Ekofisk, and then of course became the door opener for a lot of other things. It was developed in France, and I think it's an important point that we didn't invent the wheel. The concrete concept first came from France. As you saw from the previous map, one thing about the Norwegian coast, we have lots of fjords, deep fjords. They don't have that in France, and this was just a gift from nature. We had the ability to build these huge structures inshore in deep fjords. So Doris and Phillips came to Norway looking for a contractor. Luckily they found one, we took it on, and delivered the platform on time, and installed it in 1975. And this started people thinking, you know, this was a storage tank. Could this be utilized also for other purposes, for drilling and production units? And then the Condeep concept was born, and the Norwegian Contractors, and a series of Condeeps were built at Hinna and supported by a network of consultants and suppliers. This really, in those 20 or 25 years, became like a national industry. Everybody joined in. Everybody wanted to participate in these exciting projects. And then really we could draw on all the expertise wherever it was into the project. Now, how did these people have the guts to do this? Well, they had a background, mentioned already. In the 50s and 60s, we had a huge program in this country for hydropower developments. There are more than 1,000 dams all over the country, some of them huge concrete structures. We had the industrial plant, you know, we had the Tromsø Bridge in 1960, at that time, a miracle of a bridge built by Norwegian, designed and built in Norway. So we had already capacity and competence to do large, complex projects. However, we had never been offshore to that extent. So offshore was something else. Different clients, international companies, different environments, as we've seen, huge waves, tough climate, big water depths, different rules applied to this industry, and different risks. Because, of course, you realize, understand, and we should hear, there are risks associated with this kind of work. So, some board contractors accepted the challenge and moved in. And this is a concept that they developed called combi. Mainly, it has a huge base, which makes it stable out in the middle of the sea and enables us to store oil. It has sling shafts, which protects the risers and the drilling tubes and supports the deck. It is able to carry a very large topside, up to 50,000 tons. Inshore completion, this was one of the keys. This could be built in a sheltered fjord inshore and then taken out and placed there within a couple of weeks. At that time, in the early 70s, there were very few marine cranes and huge floating equipment that could be employed for these kind of structures in the North Sea. So doing this inshore and taking it out was part of the clever idea. Reinforced concrete, which is strong and durable. A brief visit to the actual construction work. On the left here, you see the Hinna yard as it was in its glory days in the late 80s. It's good Faxi in the dock, ready to be sold out. 42 meters tall in a 14-meter dock. Surely it won't float. No, it will not float. It will only be made to float by putting an enormous air cushion underneath the domes. 20 meters of compressed air. It took to lift that off the dock and take it out, and then deballast and carry on working. On the right, you see the next stage, which is the deck mating. The deck, of course, is built at the same time at a different yard, floated over on barges, and at this stage, the concrete platform is hardly visible. It's ballasted down to virtually the top of its shaft. In this case, it's Stavanger. We have 279 meters below water and 6 meters above. It's almost mind-boggling, and of course, you all know that this is risky. So, from this area, of all these platforms, what sort of handovers do we have? What can the future generations learn? I've listed here maybe what, to my mind, are the most important items. Development and structural analysis and design, they make huge, what we call finite element analysis, which is computer-run programs to analyze these complex structures. We developed much improved concrete strength and workability. The concrete we had in the 1970s was not at all due for troll. We couldn't build it with that kind of concrete. So we went through 20 years of hard work and development to produce materials and methods that enabled us to do troll. Seaform development, these were constructed by moving forms, which we lifted hydraulically and put concrete and steel in, so it sort of was a living mechanism when we built these tall shafts and cells. And the technology you can see on the right hand there, the shape, sloping, varying diameter, wall thickness, we were able to do all this in one continuous movement with hydraulic slip form. Skirt piling, the piling system that we invented to be able to put this on 40 meters soft soil. We brought the piles with us, we put them underneath in the drive, so that when it came out, we ballasted the platform and we pushed the skirts through the soft soil and into open ground, and there it was, solid as rock. Planning, obviously you realize from the previous slide that there's a lot of planning going into these projects and monitoring. You need to measure all the time what you're doing, record it, then document it to the satisfaction of your clients. And of course in this process, updating codes and standards. A lot of today's standards on large structures and concrete works come from the platform area, with input from the platform area. So today we have a set of rules which enable us to also to do these things internationally. We have a common language in common codes and standards. So now we can build in Russia and Canada with much the same methods without having to go through huge processes of negotiation. The area in the North Sea came to an end, various reasons. One being that like we saw, all the network pipelines made the storage requirements superfluous. Subsea technology developed rapidly. Construction tools offshore enabled people to put in lighter structures for smaller developments and so on. So Condeep has built an platform in Russia. You got lots of 3 concrete platforms. One reason concrete was chosen there was the ice, moving ice in that particular oil field, and of course the concrete is so robust it can also deal with that sort of issue. And the same on the right, which is an ongoing project of the headland GBS in Newfoundland, being built at the moment, finished probably early next year. And again, it's an ice load issue which favored the selection of the concrete structure. And then we have what's happening here at the moment. We have the new E39. You all know that somebody has the ambition to build a ferry-free road from Stavanger to Trondheim, more than 1,100 kilometers, and a number of deep fjords that need to be crossed and passed, most of them more than 2 kilometers wide, and no current bridge design can span 2 kilometers, so we need to be clever, think of new ideas. And some such ideas are either floating, as you see in the bottom there, which is incidentally the Nord-Holland Bridge outside Bergen, built from 20 years ago, floating pontoons. On the right, we see a proposed suspension bridge on floating pontoons for the largest Sognefjord crossing. On the bottom you see the submerged floating tunnel, which is another concept for crossing wide fjords underneath the surface. And all these are existing ideas and developments. They will happen sooner or later, and involves an awful lot of what I would call Condeep technology, offshore technology. Also in some other fish farming, concrete is moving into that arena. Maybe the concept on the left is just one of them. Strong, durable, escape-proof, and also able to catch the rubbish, which is becoming a growing problem for the fish farming. On the right, you see a proposed floating windmill. Of course, new energy off the coast in deep water. You can have them floating on a pontoon-like structure like that. And finally, different scenario, Hinna, which was our perfect working yard in the 70s, 80s, and 90s. I can't imagine a better place to build platforms than here. We had a large area, we had a very supportive local authority, we had all the services we needed around us, airport, deep water, we had first-class sand and gravel in Årdal, the raw material for the concrete. Perfect. And then when it all came to an end, we see the proposed Hinna Park. And in maybe 10, 20 years' time, it will look something like this. Maybe 10,000 workplaces and 2,000 homes. It came off as a spin-off, really, from the industrial activity that started there 40 years ago. What we need to do next can greatly benefit from paying attention to what we did in the past. I think that's the lesson that we're all trying to live with and to learn and to remember. Thank you.